Hello, and welcome to this Academy Cloud Foundations demonstration. In this segment, we will demonstrate Amazon Virtual Private Cloud, or Amazon VPC for short. Amazon VPC lets you provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. So a VPC is your very own private slice of the AWS network. You have complete control over your virtual networking environment, including selection of your own IP address range, creation of subnets, and configuration of route tables and network gateways. You can use both IP version 4 and IP version 6 type addresses in your VPC for secure and easy access to resources and your applications. There are a few moving parts related to a VPC. There is also a few ways to provision and use a VPC, including an automated way that we call a VPC wizard. So if we navigate to the VPC landing page, as we get to see here, we can examine some of the parts of a VPC like elastic IP addresses. We also get to see subnets. We also get to see routes and route tables, gateways, and a bunch of others. Please note that not all of these are required for every single implementation of a VPC. The simplest way to create a VPC takes advantage of the default VPC which already exists in each of the regions for your AWS account. We get to see on the VPC dashboard, selecting VPCs, we see what is called a default VPC. The default VPC represents prefabricated functionality so that you get to use and start experimenting with virtual machines like EC2 instances and RDS instances sooner more than later. It is also important to highlight that use of the default VPC should be considered for testing and experimentation only. In a business or a production environment situation, you want to define each and every piece of your VPC according to requirements and have them properly documented. In order for us to implement a VPC, we don't need to be networking experts. We do, however, need to be familiar with some networking fundamentals like classless inter-domain routing. Basically, this is a way to specify a group of IP addresses using a single special notation. We will see that when we configure the VPC CIDR. We also need to be familiar with the idea of an internet gateway, which is the resource to move data to and from the public internet. Finally, we need to be familiar with the idea of routes, which are the rules which dictate how traffic is going to flow into and out of our subnets. Subnets, of course, are the way that we subdivide a VPC into smaller, more usable segments. So a VPC wizard represents automation for you to define and provision frequently used VPC type configurations. In this case, we will use the Amazon VPC wizard to create a VPC, attach an internet gateway, add a subnet, and then define the routing for the VPC so that traffic can flow between the subnet and the internet gateway. So we're going to show you how to create an Amazon VPC using the wizard and explore the basic components, including public and private subnets, route tables and their route entries, NAT gateways, network ACLs, and elastic IPs. So as a first step, we will create an elastic IP address. The VPC wizard will launch a NAT gateway to provide internet access to private resources. Private resources are the type of resources that you actually land in a private subnet. These private resources basically will use the NAT gateway in order to be able to have access to the public internet. With that said, the NAT gateway will be assigned a static IP address, known as an elastic IP address. So we will create an elastic IP address now. An elastic IP address, when we select on the proper segment, is a public IPv4 address. This means that it is readable from the internet. It is a static IP address, which means that the IP address will not change. You can associate the elastic IP address with a resource in your VPC, such as a NAT gateway, as we will do, or an Amazon EC2 instance. You retain control of the elastic IP address until you release it back to AWS. So in the console, we are already on the VPC and we have selected the elastic IP address segment. We're going to click on Allocate New Address. Click on Allocate, and your Elastic IP address is displayed. Once it is displayed, we click on close, and we now have an IP address assigned to us. We now move on to create the VPC itself. We will be using the VPC wizard, which can be found by clicking on the VPC dashboard button. Notice that the VPC dashboard is the very top item on the navigation panel. If you select your VPCs, you no longer see the VPC wizards. So we're going to be selecting the VPC dashboard. The wizard automatically creates a VPC based on the parameters that you specify. Using the VPC wizard is much simpler than manually creating each component of the VPC. Until we fully understand what is going on with every piece, the wizard is the best place for us to implement a VPC. So here is a sample diagram of the VPC that we will create. We start by clicking on the VPC dashboard and then launch the VPC wizard. When we click the Launch VPC wizard, we see a number of options here. First, we see a VPC with a single public subnet. This is basically a single public subnet connected to the internet. This is ideal for applications that operate purely in the AWS cloud. We also see, as a second option, a VPC with public and private subnets. A public subnet for internet-facing resources and a private subnet for back-end resources. A NAT gateway is also launched to provide internet access for resources in the private subnet. This is ideal for keeping private resources separate from the public internet. As a third option, we see VPC with public and private subnets on hardware VPN access. A public subnet and a private subnet are created, plus a virtual private network connection to an existing corporate data center. This is ideal when you have legacy infrastructure in a data center which can connect to the AWS cloud as combined network. Finally, we see VPC with a private subnet only on hardware VPN access. A private subnet connected to a corporate data center via a VPN connection. This is ideal for bursting into the AWS cloud to provide additional resources while remaining totally secure from the internet access. This design is often used for development and testing where no direct internet access is actually required. So we will be focusing on the second option, the VPC with public and private subnets templates. Once selected, we actually get to see a diagram of the topology that it will implement. And when we click on the select button, a number of questions need to be answered. The first one is the IPv4 CIDR block. We're going to leave that exactly as is, 10.0.0.0/16. This represents a CIDR abbreviation for over 65,000 possible IP addresses. This VPC can then be subdivided into subnets using smaller, more usable blocks from this very large pool. We're not going to be using IPv6, and for the VPC name, we're going to be using my VPC. Now notice that we have a public subnet CIDR to be able to specify. In this case, we're going to be changing the third digit to 1, leave everything else the same. The /24 AWS always reserves 5 IP address for every CIDR block that you actually define. The availability zone, we're going to select the very first one, 2A, and we're going to call it public subnet 1. Now for the private subnet, we're going to change the third digit to the number 2. That is going to be creating a different block in order to be used in this particular subnet. Notice the availability zone, I kept it the same as US West 2A, and we're going to call it private subnet 1. For NAT gateway, I'm being asked whether I have an elastic IP allocation. And in fact, this is how we started this experiment, this demonstration. So in fact, we do have an elastic IP address. In this case, we're going to be selecting it. We're not going to define any service endpoints, and we're going to leave the DNS host names as is. So you get to see now with the wizard, you answer only the fundamental questions related to your VPC, change the names, allocate the IP address blocks, If you already have an elastic IP, that will be automatically assigned to a NAT gateway. And all we need to do after that is create VPC. We're going to do that now and then wait for all the resources to reach a steady state. So now we get to see that the VPC resources have been successfully created. We now get to explore our VPC. So first things first, we're going to select your VPCs. Now, above and beyond the default VPC, again, that one is considered for testing and experimentation only. It represents prefabricated functionality. We also get to see My VPC, which is what we just created. When we select on the left checkbox, you get to see a description that reminds you of the IPv4 CIDR that was assigned to it. It gives you the VPC ID and a number of other configurations that have been prefabricated in order to allow us to use this VPC sooner more than later. Now, if we select on Internet Gateways all the way to the left navigation panel, we're going to be able to appreciate two of them. One of them is attached to our VPC. Let's make it visible here. The very first one is attached to My VPC. The second Internet Gateway is basically attached to the default VPC. The Internet Gateway for our VPC is clearly displayed here, so we're going to be selecting it. And an Internet Gateway basically connects your VPC to the Internet. So if the Internet Gateway was not present, then the VPC will have no connectivity at all to the public Internet. An Internet Gateway is basically horizontally scaled, redundant, and highly available VPC component. It therefore imposes no availability risk or bandwidth constraints on your network traffic. Continue to examine our VPC, we can select on subnets. A subnet is basically a subsegment, a slice of an existing VPC. So a subnet always belongs to a specific VPC, and a subnet always exists in a single availability zone. Notice a VPC can actually span multiple availability zones, but the mapping and relationship between a subnet and an availability zone is a one-to-one mapping. A subnet always lives in a predefined specific availability zone. A subnet also has a range of IP addresses, which is usually a subset of the IP addresses that were assigned to the VPC in which it lives. So the CIDR range has already been defined for a number of subnets. We have two subnets in our VPC, and that is a public subnet as well as a private subnet. So let's select the public subnet. They actually have names, and we select public subnet 1, the way that we named it. In this subnet, the IPv4 CIDR happens to, in this particular case, be 10.0.1.0/24, giving us a potential of 251 possible IP addresses. This is because there are several reserved addresses in each subnet, and one IP address has actually been consumed by the NAT gateway. That's why we get to see 250 instead of 251. When we select the route table, we get to appreciate two local entries over here. The first one is the local route. The local route with the target local directs traffic destined for elsewhere in the VPC so that anything that is moving within the VPC can actually communicate with each other. This traffic never leaves the VPC. The second entry that we get to see uses the CIDR abbreviation for the public internet. And in this case, that is 0.0.0/0. That represents the public internet. And this particular route entry is directing all traffic to be processed by the internet gateway. So routing rules are evaluated from the most restrictive, with the bigger number after the slash, through the least restrictive, which is the 0000/0, since it refers to the entire internet. So traffic is first sent within the VPC, and if it fails within the range of the VPC, then it gets sent to the internet. The rules can then be edited based upon your particular network configuration. The fact that this subnet is associated with a route table that has a route to an internet gateway makes it a public subnet. That is the definition of a public subnet. A public subnet is basically the sum of a VPC, an internet gateway that has been attached to the VPC, a subnet that has been defined according to the instructions that we just demonstrated, and finally, a routing table that indicates that public traffic is going to be processed by the internet gateway. We move forward examining the pieces of our VPC, and we can focus now on Network Access Control List. A Network Access Control List is an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of subnets. Network ACLs are normally left with their default settings that allow all traffic in and out of subnets. So in this case, if we select the Network Access Control List that is related to my VPC, we get to see that this is a default NACL. This is prefabricated functionality that continues to assist you in making things easier and simpler for you to implement a VPC. Until you develop an understanding of all the different moving parts, creating these things from scratch can actually become difficult. We want to avoid that, and the wizard actually helps us be able to implement a well-defined, usable VPC. So we have the NACL properly defined. On the inbound rule, we get to see that Rule 100 for inbound allows all inbound traffic into the public subnet. The Rule 100 for outbound allows all traffic out of the public subnet. The second line in each of these rule sets, notice, has an asterisk, and this basically acts as a catch-all rule. In case traffic does not match any of the numbered rules, then this particular rule will be applied. And notice how it's actually denied for any case that traps it. We now go back to subnets, and when we select the private subnet, we get to examine again the IP addresses. In this case, notice 251, because the private subnet doesn't have any resources allocated to it. The public subnet did have a resource allocated to it, and that is the NAT gateway. The private subnet, in this case, is empty. And if we select the route table for the private subnet, we get to see again the local route that is taking care of having communicate all of the resources within the VPC, be able to connect and communicate with one another. However, notice that the public CIDR 0.0.0.0/0 is now being processed by the NAT gateway instance. This is a way to create a one-way street from the private subnet to the public internet. And the NAT gateway provides this traffic in order for us to be able to implement patching and updates of resources within the private subnet. The network ACL for that subnet is configured exactly the same as the other one. The default network ACL usually is wide open. We have the idea of a security group that actually applies to EC2 instances, as it will be case on the Elastic Container Service, as it is the case of actual EC2 instance, as it is the case on relational database services. And then the security groups actually act as another layer of protection, acting as a firewall. So by default, the network ACLs that are prefabricated when we provision an infrastructure like this VPC are actually open. However, that gives us then security groups for us to protect the traffic in and out of actual resources that exist. Last but not least, we go back to our VPCs and we get to appreciate the VPC that we just created. The idea of tags represents the markings that we establish in terms of name, key, and value pairs. And VPC flow logs are basically the logging mechanism that captures all of the traffic related that is moving in and out of this VPC or a particular subnet or a particular network interface. So going back to the dashboard, we get to see the landing panel and the Launch VPC wizard. This completes this Amazon VPC Cloud Foundations demonstration. Thanks for watching.